represented by a capital letter. So we'll
Okay.
take A, for
Okay.
example.
Yeah.
Okay.
Yeah.
So A is a set. Now how will you write this? You'll use curly brackets.
Curly brackets. Yeah.
Okay. So this is the way you will represent a set. Now
Okay.
inside this set,
Yeah.
you will include numbers. Numbers like any number, 1, 2, 3. You can also include negative numbers. It has to be an integer.
So, but integers are whole numbers, no? So their negative numbers are not integers, it seems, no?
Negative numbers are integers.
Yeah.
Integers, yeah, integers. So there's a number line wherein if you have this quadrant.
Yeah, I know. From 0 to the right are positive numbers, to the left are negative numbers.
Yeah. So all those numbers can be included inside the set.
Okay.
Okay.
Yeah.
But right now we'll talk only about natural numbers.
Okay.
Because De Morgan's law
Yeah.
is useful, or it is like mostly applied
Okay.
to natural numbers. Now it's not restrictive,
Yeah.
but most of the cases or most of the problems
Yeah.
are with respect to natural numbers only that we find in the set. Okay.
Oh, yeah.
So this is my set.
Yeah.
Okay. And this is how you will write your set.
Yeah.
Okay.
Yeah.
Now what we are going to do is we have to understand something called union and intersection.
Yes. Union
Okay.
of two sets and intersection of two sets. Yeah.
Correct.
Yeah.
Okay.
Yeah.
So for union, now what do you mean by union? Like just
Combination or merger. Combination or merger.
Correct. So
And union is represented by a U, no?
Yeah.
And
correct.
Intersection by an inverted U.
Something like this. A union B.
Yeah. Correct.
Okay.
Yeah.
So I have two sets with me. Can you tell me A union B would be what exactly?
Achha, this is not one below the other, no?
No. These are two different sets.
Okay.
They are not one.
Because you put a line, no? I thought it is numerator and denominator. Yeah. Okay.
No.
I thought you were going to divide now. I was scared. How are you going to divide? Okay. Yeah. Okay. A union B. A union B would be 1, 2, 3. 1 minute. You got 1, 2, 3, and you got another number there, -2. But
Yeah.
But you said only natural numbers.
You can exclude this -2.
Okay.
It was just explanation
Okay.
that I gave.
Got it.
But you can exclude this.
Alright. So it would be 1, 2, 3, 4, 5, 6.
Correct. 1, 2, 3, 4, 5, and 6.
Yeah.
So this is your union. A union B. Correct?
Yeah.
So now, what I was telling you is, A union B would be including all the numbers of the set.
Correct.
Okay.
A intersection
Now,
B would be 0. Nothing is in common.
Correct.
Yeah. Because
So
we learned it in school, set theory in 9th standard or something.
Yeah, correct. So A intersection B. Now these sets are very important for understanding De Morgan's law. So that's why I'm making sure that basics are very clear for this.
Yeah.
So A intersection B would be 0, right?
Correct.
Okay. Now we'll move to something called as complement. Okay.
Yeah.
So complement is represented by 1. So, do you remember in our yesterday's session, we had something called as negation?
Yes.
Yeah. So, can you tell me what was that negation about?
Negation was opposite of whatever was there.
Correct. So, same thing. Complement is something which is not there.
Yeah.
So, if I have to say complement of A.
Yeah.
Okay. So, complement of A would be anything which is not there in this set A. Okay.
Yeah.
So, for this I have to introduce something called as union. So, this entire thing, this is again one set, right? 1, 2, 3, 4, 5, 6. So, this is your main union set.
Okay.
And this is A.
Right.
So, complement of A will include everything that is not there in your A
So
set,
it will be 4, 5, 6.
but
Huh?
is there in your union.
So it will be 4, 5, 6.
Correct.
Okay.
So this is the representation of a complement for a set A.
Yeah.
Okay.
Yeah.
Okay. So I think you are clear with union, you are clear with intersection, you are
Yes.
clear with complement.
Yes.
So now we can start with De Morgan's law.
Yes.
Okay.
Yeah.
So first I'll explain the law.
Yeah.
So this law is basically
Yeah.
an equation but in the form of sets. Okay. Now what is that equation? I'll
Equation,
tell
but
you.
in the form of.
Sets.
Okay.
Okay.
Yeah.
Sets which also includes intersection and union both.
Okay.
So the equation of De Morgan's law
Okay.
is, so we have, I'll take two P and Q sets, okay?
Yeah. You know, when I was long back, no, in 1993, I used to give home tuitions as to go. I was studying in South Bombay, no. So Saturday, Sundays, I used to
Okay.
go and teach French and all to school students. I used to get like 100
Okay.
rupees an hour. I used to take 2 hours
Wow.
together. At that time, 1993, that was through Kumar Tutors Bureau. It
Okay.
still comes in the newspaper, you know, Mr. D. Kumar. He's got Private
Okay.
Tutors Bureau, sorry, PTB.
Great. That's great.
I used to earn like 200 rupees on one weekend, but then taxi to go and come to Valkeshwar and all from St. George Hospital, that is CST. It would cost also some money, but I was not bothered. Yeah.
So like you like shifted recently to Vasai or like
No. I bought this flat in 2002.
Okay.
Yeah, so when we were here, we were in Andheri actually. My parents used to stay in Andheri. Now they shifted to Goa.
Okay.
But to buy a flat, you know, my father had bought me a flat in Mira Road, but I had to sell it, you know, because I needed the money. This was in 2011, 2010, end of 2010. But this flat, I bought it here because it is cheap, na? It is not expensive.
Yeah.
That's why.
Like here the rates are cheaper than Bombay rates.
Property tax is less, food is less, everything is less, na? And I didn't have after coming back, I was not getting a job, na? Here, that's why.
Okay, so what was your previous job like?
I was in the UAE, I was working as a dentist only.
Okay.
Then I worked in COVID hospital, by the way, under BMC.
Oh wow.
Yeah, the doctors only were killing the patients. by negligence. Means like they are, in 4 hours.
Like you also did civil engineering, right?
I did civil engineering recently. That is after I applied. I answered NEET, to answer post graduation MDS in orthodontics. But you need very high marks. I just got 35% percentile or whatever. Yeah, so I would never get. So then you need lot of capitation, for which actually it was possible at that time in 2012 if we had sold some land. But at that time, it was not done. Now the prices have fallen, and now of course I don't want to do in orthodontics, because now I've shifted to engineering. Because how long are you going to clean people's teeth, This was not people's teeth. This was orthodontics, means the star bithana, So it was simple. I could have worked as a guest lecturer, like visiting lecturer in college. I could go abroad for 1 week and come back. A lot of things I could have done. But everybody had given up on me, my parents, relatives and all, and they're giving more importance to my brother and his children, because they have more hope in the next generation now. This one is like, I'm like, you send her to the UAE and she comes back. So they're seeing me as a loser, which I'm not. But they have like given, and they're very old also, na. And it's my brother who's taking care, and his family who's taking care of them. So I'm not the one who's taking care of them. So they are more, so they are more invested in that. All the money and all, everything they are feeling very this thing about stingy about spending on me. Like, I'm very shocked to see this. Suddenly how I became second class citizen, So I am very shocked, because this was never the case when I was young. I never knew there was a difference between me and my brother. If at all, I was better. I was given more attention. But now everything has become ulta. I'm very surprised. Kya ho raha hai, So I'm struggling to survive. I'm in the love shadow of my parents. right now. For no reason, even though I'm trying my best. And my brother is not very good at accounting, but he's got a job. And my brother's children and all have got on capitation. Understood? I'm the one who's getting into government college and all, but still, they are like, khunnas, dikha rahe, as if they're getting some pleasure out of it. I don't know. I don't know what is going on, Kuch to, like somebody is doing something to their mind or what, I don't know.
So I think after, like once you graduate and once you land a good job,
yeah, then
I think
everything will
pay
be fine.
more attention
Then
to you.
everything will be fine. Yeah, so till then it's a struggle. Until then, after that there's no problem. But this is like new territory for me. I'm like struggling to understand क्या हो रहा है. Parents भी ऐसे हो सकते हैं क्या? I mean, really, this is a
So
real.
like here you live alone.
Yes, I live alone in a 2 BHK flat with my with some stray dogs.
Oh.
Yeah.
Wow.
Yeah.
Okay.
Yeah.
So
Okay. Yeah.
this is the equation of De Morgan's law.
Yeah.
Basically, this law is to prove that this LHS is equal to RHS.
Let me just write that up. P union Q.
P union Q.
And this is called complement. Complement is equal to complement of P. Complement of P. Intersection of complement of P and complement of Q. Now, now you gave me two sets A and B. Now, how where did this P and Q come from?
Yeah, so I'll tell you. These are just the naming convention of a set. You can name it anything, not just P and Q. Any names you can give. Okay. Yeah. What is important? What is important is this equation, the union, the intersection, the complement. These are important. Naming can be anything. Right. Okay. Yes. So basically, this law says that this union complement
I just thought of asking you a question. You live in a joint family? Is it a joint family? Or they just guess who came over for Ganesh Chaturthi?
It's a joint family.
Okay, because it's a huge house. It's a big house.
Yeah.
And you have a brother also?
Yeah.
There's partiality between you and your brother from the parents' side?
Yeah.
Oh, okay. This is
I am used to this.
This is an Indian thing, yeah? This is an Indian thing.
Yeah.
Which I'm just understanding, like with great difficulty. I'm understanding. Anyway, no problem. That's out of the question. I'm 50. I have other things to think of. Yeah.
So, basically, this law is basically telling or proving that complement of a union will be equal to intersection of individual complement.
Correct.
Okay. Yeah. So we just have to prove this. Yeah. Okay. Yeah. Now, they have just, in the question, they are telling you to state the De Morgan's law, right?
Correct.
So first we'll explain them, or first we'll give the definition, and then we can give a proof also. Okay.
But they're not asking for proof.
They are asking, right?
No, they are not. No, are they asking?
They are not.
No, in the question bank. In the question bank. Let me just have a look at the question bank now. Let me just look at the question bank. This is just state De Morgan's law, I think. This is just state De Morgan's law.
Yeah, but like what we'll do is we'll write both. We'll write this also, because sometimes if it comes for 5 marks, then you have to even include proof also.
Okay.
Right. Yeah. So first we'll do the definition. So as I told you.
No, but Jahnvi, we'll just stick to the question bank for now. Later on, we'll see if I need the proof. I'll come back to you. Yeah.
Sure.
Because so that we can do more number of questions, na? Because you're explaining so well, I got an idea of what De Morgan's law is.
Okay, so what we'll go with the definition then.
Yes.
So for definition you have to remember this equation. Union. Yeah. How you'll remember this? Union first, intersection later. Yeah. Okay, this is a code word that I told you. Now how you'll remember this? Union first, intersection later. First you'll do a union.
Yeah.
You will do a whole complement.
Yeah.
Then you'll do an intersection, and then you'll do individual complement.
Okay.
Okay.
Yeah.
So I'll teach you.
If you tell me the definition, I'll just write it down.
Yeah. So what you will write is De Morgan's law.
Yeah.
States that.
Okay.
The complement.
Yeah.
Complement.
Yeah.
of the union
Yeah.
of two sets
Yeah.
is the
Is the okay.
intersection
Yeah.
of their complements.
Of their individual complements or something like that.
Yeah, anything works. Of their complements or of their
No, no, no,
individual
no, no.
complements.
Of their complements is fine, provided it's okay, you know.
Yeah,
Of because you've written two sets.
yeah.
Either then you have to specify is a intersection of the complement of each of the two sets. No, you don't have to write that. Okay, you have to
We
just
can
write.
just say of intersection of their complements
Yeah.
because any which ways we have written here.
Correct, correct. Of
The
the
first
and
set.
they are refers to the two sets individually.
Yeah, yeah.
Correct. Got it. Got it.
Okay.
Yeah.
So
And
if
this
we have
definition
to,
you got from the textbook.
not from, this is my own wording.
Okay,
No,
then
none
I'll
of
just
the
check it. Then
textbook.
I'll just check it up also or somewhere to get the
Yeah,
words
yeah.
right. Yeah.
Like this is the most simple definition to make you understand.
Yeah. I got it.
A De-Morgan's
I got
law.
it. I got it.
Yeah. Like mostly in textbook also some sort of this will be there.
Yeah, it'll be
But
this only. But I
wordings
just
will
want
be
to know
different.
whether you have to specify that it will be the intersection of the complement.
Yeah.
Of,
These words are very important.
yeah, intersection of the complement
union.
instead of their complements should be right. Intersection of the complement of each of those two sets. Like should be specify
Yeah.
that. You know, like legal language, you have to specify.
Yeah.
Yeah.
Okay.
Yeah. No, but what you wrote is very beautiful. Like, you know, it's not like extra and complicated and all.
Yeah, like
Yeah.
I just told you very simple
Yeah, and
things so that-
I think that is the correct thing, but I'll check it again. Yeah.
Yeah, just check for maybe if they have any specific wording.
Correct.
Okay.
Yeah.
Can you tell me the next definition?
Yeah, sure. The next question actually is in the question bank. It is explain the principle of mathematical induction.
Okay.
Is that also a module 1?
No, this is not module 1.
Which one is it?
This is, I think this is of binomial equation because this is mathematical induction, right?
Okay.
Yeah, so this has to be module 2 or like module 3 is lattice, so it is not module 3. Module
Okay.
2 is this one. Okay, so we'll move to by mathematical induction ka principle.
Yeah. Oh,
So,
but yeah, mathematical induction is in the first module of logic. It says that logic, propositional logic, predicate logic, laws of logic, duality, quantifiers in the syllabus. Yeah, binary predicates and mathematical induction.
Acha, then what is module 2?
Module 2 is relations and functions, basic concepts of set theory, and relations, definition, types of relations.
So this was module 2, De-Morgan's law.
Okay.
Acha, I thought there is a separate module for binomial.
Binomial is not mentioned anywhere. 1 minute. Closures of relations, Warshall's algorithm, equivalence relations, and equivalence classes. Okay, that is identity and inverse functions, definition functions, definitions, types of functions, composition of functions, identity and inverse function. So that is 2. So binomial is not mentioned anywhere. I'll just go to number 3. Cell relations, inverse. Acha. Okay. Yeah, self-learning topics are given. Operations on relations, complementary relation, inverse relation, intersection and union. Okay, that is in module 2. And module 3 is partial order relations, poset, supremum and infimum, Hasse diagram, lattice, types of lattice, sublattice, distribution. But this binomial is not mentioned anywhere, huh?
So binomial is not there only.
Yeah. Okay.
It was there in our times. We had binomial.
Okay, so this is AI and ML, no? So it's inferior to electronics. Yeah.
You guys are lucky because binomial.
Yeah.
Very complex.
I hope I get luckier, huh? Because even this is a lot, yeah. No, I'm lucky that you also responded, na, to this super prof thing, and you're in Vasai only, and I could meet you. No?
Yeah.
I think that is great,
Yeah.
yeah.
Okay.
Yeah.
So we have mathematical induction.
Yeah. That's the question. Just stop one second.
So yeah.
No, tell me. Yeah, I'm here.
So
Yeah.
basically,
Yeah.
mathematical induction is applied, like this entire induction is applies to
Yeah.
natural numbers. Okay.
Okay.
So the theory order, you can say the definition would be that
Yeah.
it is a theorem or a technique
Yeah.
for every natural number n.
It is a theorem or a technique.
For
Yeah.
each and every natural number
Okay.
which is thought to be true.
This is your own definition.
Yeah,
So do you want to just check it somewhere? Google or something?
I'll just check it now.
Yeah.
Okay. Okay, I have one more definition. It's little formal, but I
Okay.
think this is good.
Yeah, formal, yeah.
The principle of mathematical induction
Yeah.
is a mathematical technique
Is a mathematical technique
for proving
for proving
that a statement
that a statement
is true
is true
for all natural numbers.
for all natural numbers. Okay. But why they call it induction? What is induction?
Because in the so in this entire mathematical induction, it's a three-step process.
Okay.
So first is the base case, where what you do is you will put n is equal to 1 because natural numbers start with
What
1.
you said?
Right?
It's a base. Base, you said?
Base case.
Pardon?
Base case. BASC. Base case.
Base, I understood. The next word is base case. Okay. What is a base
Yeah.
case? What is a base case?
So for this mathematical induction,
Yeah.
it is solved or it is applied via three steps. First is the base case, where you put the value of n. N is a natural number equal to 1.
Where you put the value of n is equal to 1 and n is a natural number.
Yeah. Then comes the inductive state.
Okay.
So what happens
What is the meaning of induction?
So inductive basically means to induce, right?
Okay.
To increase. So here we'll increase the value. So
Okay.
here what we'll do is
Yeah.
we will say this n is equal to
Yeah.
1
Yeah.
plus k. K is again some natural number.
Okay.
Okay.
Yeah.
So we'll increase the value.
Yeah.
Next, like 1 plus k.
1 plus
K.
k. Yeah, got it.
Okay.
Yeah.
So, okay. So, they are just asking definition or they are asking you to solve the principle?
No. Just the definition.
Okay.
Remember,
So,
this is not Somaya College. Here they just want you to pass.
Okay, so you have the definition, but
Yeah.
you can also include this base case and inductive step.
Yeah.
Okay.
Yeah.
And last thing
Yeah.
will be that we will say
Mm.
the result of
Yeah.
this induction
Yeah.
will be true
Yeah.
for all positive, not positive, for all natural numbers K.
For all natural number?
K.
All natural number cases, yeah?
Yeah.
Okay. But can you give me an example
So-
of this principle of, like, is there an example?
Yeah, I'll give you.
Yeah. So I'll remember.
So suppose,
Uh,
so what will happen is,
yeah.
so this is a general statement
Yeah.
that they give
Yeah.
cube is there.
1 cube plus 2 cube plus 3 cube plus
N cube
n cube
equal to n plus 1
is equal
upon 2
to
square
n plus 1
upon 2
upon 2
the whole square of the entire bracket.
the whole square, you said?
Yeah.
Okay. Got it.
Yeah. So basically, to prove this equation is proved via mathematical induction technique.
Okay.
So we just learned that mathematical induction applies to all natural numbers, or it is true for all natural numbers.
Okay,
right?
got it, yeah.
So we'll start with the base case. N
Yeah.
is equal to 1.
Yeah.
So we'll apply this over here.
Yeah.
So what we'll get, 1 cube is
1.
1.
Yeah. 2 cube is 8.
Correct.
3 cube is 27
Correct.
plus
N cube is 1.
n cube is 1.
N is 1, right?
Yeah.
N equal to 1.
Yeah.
So 1 cube will be 1.
Yeah. But then why you wrote? Got it. Because that's the
No.
base case. That's the base case.
Correct.
Huh.
So N equal to 1 we are assuming,
Yeah.
right?
Yeah.
So this is our LHS.
Yeah.
Okay.
Yeah.
Now we'll move to the left hand part, that is
Right
N
hand
into
side.
N plus,
Okay.
yeah,
Right hand side.
right hand side.
Yeah.
So we have N. N is what? 1.
Hmm.
1.
Hmm.
1 plus 1
Hmm.
upon 2 the whole square.
Let me just write that down.
Yeah.
1 plus 1 upon 2 the whole square. Yeah, got it.
Okay.
Yeah.
So 1 plus 1 is 2 upon 2.
1 plus 1 is 2 upon 2 the whole square.
So this 2 and 2 gets cancelled. You will get 1.
Yeah. So 1 square is equal to 1.
Is
1.
1.
Yeah.
Right.
Yeah.
So that means
Huh.
you can say that you got P of, so this entire box that we solve is a function, we can say, right?
Why do you call it a function?
So function will have multiple things. It will have a number, it will have a variable, but it will not have an equal to sign. It will just be a binomial, not binomial.
Function will have a number.
No binomial.
Function
will have numbers,
yeah,
variables, and operation sign like plus, minus.
Yeah.
And it will have brackets.
And brackets. And what it will not have?
It will not have equation.
Okay.
Like equal to sign will not be there. Then it's not a
Okay.
function. Then it will be an equation.
Okay, it will not have a equal to sign.
Yeah.
Which means that it is not an equation.
So P of n, now n was 1, right?
P was what?
P of n.
P of n, yeah.
So I am equating this function as P of n.
Okay.
We are assuming this value as a function
Yeah.
P of n.
Yeah.
Why n? Because we substituted the values of n, right?
Yeah.
So P of n equal to P of 1.
Yeah.
Why 1? Because we substituted n equal to 1.
On the left hand side we didn't get an answer, no? On the left hand side we didn't get an answer, no? Because that is plus dot 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 plus 1.
Yeah.
So left hand side we don't have an answer, no?
We don't have an answer.
Okay.
For left hand side.
Okay. So left hand side we are writing as it is P of n.
It will be a generic. So it will be a generic thing where n cube will be 1 cube. Rest everything will be same.
Rest everything like it will be plus 4 cube plus 5 cube.
Yeah. Like
But-
1 cube, 2 cube, 3 cube plus n cube. So only we'll substitute 1 here.
Yeah. But this will go on for how long? Like 3 cube, 4 cube, 5 cube, till infinity.
So n is your natural number.
Yeah.
So till positive infinity, it will go on.
Okay.
Yeah.
Okay. So therefore you're calling it a function because it does not really have an answer.
No. So it's not right in case of function. If you have, so it's here. If you have the value of n,
Huh.
then this is a finite thing, right?
Right.
So then this will not be a function.
Okay.
Okay.
So a function is when it is infinite.
Yeah.
Okay.
No, function is finite,
Huh.
but only if you have the values of variables.
Correct.
Okay.
Yeah.
So P of n is equal to P of 1.
Yeah.
And this P of 1 is also 1 because we solved this entire thing and we got 1.
Yeah.
So the value of this function is 1 basically.
Yeah.
Okay.
Yeah.
So what we arrived is
Huh.
1 is a natural number, correct?
Yeah.
So that means this part
Yeah.
is giving us a natural number.
Yeah.
And mathematical induction was also telling
Yeah.
that it will apply to all the natural numbers only.
Yeah.
Now we look to this one.